Sanibonani nonke emakhaya. To all those who are doing physical sciences, siyanibingelela. Namhlanje guys sokubereka nesifundo sethu namhlanje physical science, photoelectric effect. La previously bengadweba i-diagram ekanje. So ngithikelana ke labo line laba ba-representa i-light. Sezwa lento engishoyo. Into engifuna uku-emphasize namhlanje ukuthi i-light ine-energy, alright? And inani ine-frequency. Into engifuna uku-emphasize ukuthi mangaba i-frequency i-increase, i-energy iya-increase. Let me repeat. When the frequency is high, also the energy is high. In other words, frequency is directly proportional to the energy. Coming back to this, when this light is incident on this surface, that means the electrons here will be ejected and will have a maximum kinetic energy. Once again, we must remember every material, whether it's gold, it's platinum, it's silver, blah, 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 or bronze. Now, every material has got its own work function. What is work function? Work function simply means minimum energy that an electron need to be ejected from this material. Okay? Magna work function une threshold frequency. Okay? So interested on here is to eject electrons. I repeat, in order for the electrons to be ejected here, the energy of the incident light must be greater than the work function. Then the electrons will be ejected. Okay, ladies and gentlemen? So let me give you now the full definition of photoelectric effect. That photo is the process whereby the electrons are ejected. Process whereby electrons are ejected when a light of suitable frequency is incident on the metal surface. To all of you guys, you must understand the definition of photoelectric effect. Process whereby electrons are ejected when a light of suitable frequency is incident on this metal surface. That's it. Then now we come from here. I said this light is coming with its energy, that is shining on the surface of this metal, and the electrons here will be ejected once the frequency of the incident light there is greater than the threshold frequency here. So the electrons will be ejected. So this equation, that is energy of the photon here, must be equal to the work function, that is work function is on the material, plus the maximum kinetic energy, that is now of the photoelectrons. That's the equation we'll be dealing with here today, guys. So this equation now is Very, very, very important to manipulate. Okay, let's remember E is also equal to H times F. So remember, H implies the Planck's constant. And this one is a constant, is always equal to 6,63 times 10 to the power minus 34 joules second. This is Planck's constant. So whenever the question asks you to find the energy of the incident light, you can find that energy using this formula. Also, you can find work function. Work function is related with the threshold frequency. You remember that? Minimum energy an electron needs to be ejected from the metal surface. That's the minimum frequency an electron needs to be ejected. You see that? So this is it. Also, you know that maximum kinetic energy is equal to half mv max squared. So putting these together, you know now. So guys, this is very important for you to understand. That's it for today. That's all I wanted you to know about. Thank you very much. See you in part number 7.